Here we go. Algebra, Chapter 4, Section 3. Writing equations of parallel and perpendicular lines. One of the keys to this lesson is understanding slope. Okay, understanding that rise over run. Let's think of things that are parallel. Train tracks, sides of the road, sides of a rectangle, the sides of the board that I'm writing on here, opposite sides, those are parallel, and so they never touch. And so in slope, parallel lines have equal slopes. So let's say I had the slope of a line was 1/2. If I had the slope of the line of being 1/2, every line that's parallel to that, forgot an L there. Sorry, guys. Every line that's parallel to that would have a slope of 1/2. And so perpendicular lines are just a little bit different. Okay, now we need to understand what perpendicular is. Perpendicular means it creates a 90-degree angle. So you're looking at the wall and the floor, the ceiling and the wall. When you're standing upright and getting your height taken at the doctor's office or whatever it might be, that is perpendicular. The flagpole to the ground, light pole to the ground, as I'm looking out the window here. And perpendicular lines have negative reciprocal slopes. And I'm going to give you an example of what that looks like. So let's say I have a line. Obviously, equal slopes for parallel is simple to remember, but negative reciprocal, that doesn't sound very easy, but it is. I hope you'll find it quite simple. So let's say I have an example of a line that has a slope, and we'll use the 1/2 that I did on the one up above. What is the negative reciprocal of that? Well, we're doing two things. We're changing the sign. Okay, so we're changing the sign, so it's negative 1/2. Okay, this is step 1. And then step 2 is we're taking the reciprocal of that. Now that's a fraction term. Remembering your keep it, change it, flip it. Your flip is the reciprocal, so I'm just turning the fraction upside down. So now it becomes 2 over negative 1. Now you could leave that, or you could just write it as negative 2. It's the same answer. So negative reciprocal means I take the opposite sign and I flip it. Okay, so what's that going to look like? Well, let's start off with parallel. Let's say I have something, I've got a line, I don't want to do that. I want an actual point. Okay, so I'm drawing this line. Just like that. And I want to draw a line that's parallel to it. So again, rewinding, if it's parallel, it's got the exact same slope. So we need to find the slope of this one. So we're going to do rise over run. So this thing is going to rise and run. And let's look at those numbers. It goes up 5. So that's a positive direction. And it goes to the right 5, which is also a positive direction, which means my slope is 5 over 5, or just 1. So if I'm going to find something parallel to that, it has to have a slope of 1. Well, let's just make one. So let's say I have, this is one of my points. If my slope is 1, I can go up 5 and to the right 5, or I can just go up 1 to the right 1. And it does the exact same thing. And so you will see, as I put that line on there, because it has a slope of 1, then these two lines are parallel. Okay, so they may give you some and you have to determine if they are parallel or not. So what you would have to find is maybe use that slope formula, maybe use rise over run, whatever it takes, just to determine if that's if those are parallel or not. And then just a simple yes, no. Now, perpendicular. If I have this line right here, and I wanted to find something that's perpendicular to it, well, again, I would need to find the slope, and I've done the math on this one, so I can speed it up just a little bit. That slope is 1 again. And so if I'm going to take the negative reciprocal of that, first make it a fraction, first change the sign, and now flip it, which is just negative 1. Okay. So how could I find a line that's perpendicular to it? Well, I could start on any point on that line, and I'm going to pick this one right here, 0, 4, and I'm going to do a slope of negative 1, which, again, that's negative 1 over 1. So that's going to go down 1 and to the right 1, down 1 and to the right 1. And so as I draw this, it's going to look something like that. And that, my friends, is a right angle. That's what the little box will mean. Okay, so that means it's perpendicular, creates a right angle. And they'll give you different examples. So let's look at, let's actually I'm going to take a problem out of your book, spend a little time on this one. This will be number 10 on your work. And 10 gives us a coordinate of 1, 2. And it gives us an equation of y equals negative 5x plus 4. Okay, y equals negative 5x plus 4. And I want to do this one on a graph. And that coordinate again was 1, 2. Okay, so what it's asking is it's asking for a line that goes through that point. So I'm going to put 1, 2 on my graph. The line is going to go through this, and it wants it to be parallel to this one. Okay, so if it's parallel to y equals negative 5x plus 4, that means they have to have the same slope. So the slope is negative 5. So I'm going to go from my point, 1, 2, and I'm going to go down 5 spaces because it's negative, 1, 2, 3, 4, 5, and over 1 space. And I'm going to do that one more time, 1, 2, 3, 4, 5, and over 1 space. And so that line is parallel. Now, what it's asking for us to do is it's asking for the equation. And so we know that it's going to be y equals negative 5x because they have the exact same slopes. And now we need to see what its y-intercept is. And it appears to me that it crosses right there at 5 spaces up on the y-axis. So the equation ends up being y equals negative 5x plus 5. And that should do it. That's chapter 4, section 3, equations of parallel and perpendicular lines.